Hello and welcome back. Today we are going to be talking about volume and surface area. So we're going to talk about nets. A net is basically the unfolding of a three-dimensional shape, in particular a prism of some kind, or maybe a pyramid or a cylinder. Let's take a look at a rectangular prism. So on the left here, right over there, we've got a rectangular prism, and you can sort of see that I made it sort of translucent, so you can kind of see through it. But the important thing is that we've got three visible sides. We've got this red side, we've got a yellow top, and then a blue side as well. Now imagine that we're going from the first picture to the second picture, and we sort of unfold it so that the blue side is unfolded down to the floor, and the red side does the same thing. And then we'll do it one more time until all of the other sides are completely flat. And what we're left with is the net of a rectangular prism. In this case, it actually looks more like a cube, but the idea is that as long as we can end up folding that shape back up into the prism, that means that is a net. So we might have a few different nets. So a few that I can think of is, well, the one that we have right here. So this would be a net right here. So we've got 4 squares on that side and then 2 sticking out. But there's also a whole bunch of different versions of nets depending on how you unfold it. So this could also be a net like this. You could have these 4 sides, and then maybe those 2 squares are at the top. You could still fold this up into a cube. They just look a little bit different. There's all sorts of different types of nets, and there's really no net that's right or wrong. You can make all sorts of different types of nets. So the net of a cylinder is a little bit different because it's not actually a prism, right? But imagine that we have something like a can of soup, right? Let's say that we got some Campbell's soup here, and we kind of peel off the top part right over here. And we also use a can opener and cut off the bottom, but just leave a tiny little bit so it's not falling off. And then at the same time, we're going to cut the sort of the side part so that we can actually unfold that. So then the next image would look something like this, where we have sort of an opening of the side walls right over here, and the top and the bottom, these parts are still sort of opening up. And then when we completely flatten it out, this is what we're left with. So we have the flat side right over here, and the round top and bottom right over here. So this would be the net of a cylinder. Now, just like with a rectangle, there's many different types of nets that you could use. So, I mean, something like this could be the net of a cylinder like that. There's no reason why these have to be sort of on top of each other. So the top and the bottom circles, they could be sort of one on one side, one on the other, that kind of thing. That would also work. So the surface area of a 3D shape is the area of that shape's net. So if we want to calculate the surface area of a 3D shape, we need to find its net. And once you find its net, then you got its surface area. It's as simple as that. And the surface area of a shape is measured in square units. So you should have meters squared, kilometers squared, or maybe even feet squared. So our units are these little square units, right? So this would be 1 by 1. So if we're dealing with, I don't know, meters, then this would be meters squared, right? Now, volume, the volume of a 3D shape is a total amount of space in it. So the units are, they'll be meters cubed, or kilometers, I don't know why it does that. And finally, we are going to talk about volume. Now, the volume of a 3D shape is the total amount of space it takes up, and that's measured in cubic meters, cubic units. So for example, we could have meters cubed or kilometers cubed, or maybe even inches cubed or anything like that. The important thing is that we'll have a 3 as an exponent on our unit. So the general gist of it is that how many of these little 1 by 1 by 1 cubes, so a cube that has a side length of 1 meter by 1 meter or 1 by 1 meter, so that would be a meter cubed, or maybe kilometer or inch, or whatever your units are. So how many of those can you fit inside of your shape? Now, sometimes we might actually have to sort of squish these down a little bit, so they might not actually be cubes. So think about this, pretend that maybe this was like a cup that's empty and you're filling this up with water. So how many of those can you fill inside of your shape? Because not all of your shapes are nice and square, right? I mean, for example, if you had a cylinder, right, like that, then you're not going to be able to fit a whole lot of those squares into it. Or maybe you could maybe even fit, like, I don't know, maybe 2 of those squares in it, right, like that, one on top of another. But you can see that there's still going to be a lot of space left. So think about all this extra space that you'd still have to fill up. So think of these as sort of like the liquid version of it. Like maybe that's made out of Jello or something. You can really squish it in there. So how many of those can you fit inside of your shape? So we're going to go over some of the formulas in the next video, but just as a little gist, if this is a 3 meter by 3 meter by 3 meter shape, well, we're going to ask ourselves, how many of these 1 by 1 by 1 cubes can we fit in there? Well, if we look at this first section right here, right over here, well, I hope that you can see that we'd be able to fit 9 in this first row, right? So we would have 9 in this row in purple, right? 9 all along here. And then, so I'll sort of shade these in purple. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in, let's do yellow. This next row here, right behind it, well, that has the same amount as that first one, right? It's just an exact copy because it's a prism, right? So with a prism, the nice thing is that anywhere I slice it, I'm going to get exactly the same shape just later on. So that would be another 9. So in the first row, I've got 9 meters cubed. In the second row in yellow, I've got, oops, not 3, I don't know where that came from. I've got another 9 meters cubed. And how about in blue? Let's do this last row. So right over here, we'd have, well, another copy of it. So it would be another 9 meters cubed. And, well, 9 plus 9 plus 9 is, let's add all that up. Well, that would be 27 meters cubed. So that's just a quick and easy way of calculating it. But we're going to be looking at some of the formulas in the next video that should help us get a greater understanding of how to calculate the surface area and volume of these different shapes. Alrighty, thanks for watching.